Hello, everyone, and I welcome you all to another session of Python programming series. This is Ramprasad Pujari. In this session, we will focus on one more unsupervised machine learning technique, which is called as DBSCAN. The DBSCAN full form is density-based spatial clustering of applications with noise. This is an unsupervised machine learning technique similar to K-means clustering, which we have seen in our previous video. So this is a clustering method which is used to group data points or samples into different clusters. The main purpose of this is to separate the high density regions from low density regions. High density regions where the data points are densely packed. So let us look at the difference between k-means clustering and dbscan. K-means clustering we have seen in the last session where we need to identify k value first. We need to choose k value. K indicates the number of clusters. So k-means clustering is very sensitive to outliers and noise. If you look at this particular graph, you have all these data points which are densely packed. This is the high density region. There is also high density region. Whereas these data points are in the low density region. They are not densely packed. So they are considered as outliers. So outliers are the data points which are much away from rest of the data point. So similarly, if there is a random data point, we call it as a noise. So k-means clustering algorithm is very sensitive to these outliers and noise. Means when we compute centroid, these outliers and noise may affect the position of the centroids. So, and one more thing, k-means clustering, we need to first specify the number of clusters, that is k value. There are different methods to get optimal value for k, but it has to be specified beforehand. Whereas in the case of dbscan, automatically it determines the number of clusters. So that is the main thing. And one more thing, dbscan separates the high density region from the low density region. So low density region where there's a chance that outliers and noises may occur. So therefore, dbscan clustering is much better, especially when there are outliers and noises in the data. Another advantage of DBSCAN is the DBSCAN works well even when the data points are distributed in arbitrary shape. Whereas k-means clustering, it assumes spherical shape. If the data points are distributed in spherical shape, then easily we can group them into different clusters. But k-means clustering will fail when the clusters are not of spherical shape. If we have a data point distribution of this kind, then k-means clustering may fail. But the dbscan, it works well even when you have a arbitrary shape. So in the practical session, we will create a data set of data points which are distributed in this fashion, and we will see how this can be grouped into different clusters. So let us look at some of the important parameters of dbscan. Epsilon is one of them. So this indicates two points are considered to be neighbors if the distance between them is less than or equal to epsilon. So if you look at this, a cluster is formed by small neighborhoods, just like these circles. So each circle has a radius, and this is nothing but epsilon. So in this case, we assume epsilon is 1 unit. So this is the radius of that circle, and each circle should have, or each neighborhood should have, a minimum number of points which are defined by us. So let's say in this case, minimum number of points is 7. So this is a neighborhood because it has got 7 points, and the radius of this is epsilon. So epsilon and minimum number of points or minimum number of samples, these are the key parameters in dbscan. Now, any point here, let's say you talk about this core point. So this is a core point because within EPS distance, minimum number of points are available. That is 7 in this case. This is not a core point. This is called as a border point because it has got less than minimum number of points. So similarly, we can have a noise point, etc. So epsilon and minimum number of points are the two crucial parameters in DBSCAN. And there are different methods or rules that we can use or we can apply to compute these two. So in order to, in a practical session, we will see either we have to assume epsilon and minimum points during initialization of DBSCAN, or we should use some methods to compute them and then use. The code that you see here is available on Kaggle. Okay, so let us look at the steps involved here. Step one is importing necessary libraries. So four different libraries are imported here. The first one is matplotlib, which I use for creating scatterplot. So then we need make underscore circles for creating a synthetic data set. So we are going to specify the number of data points using make underscore circles. So then we need a standard scaler to scale our data set. And finally, an important class called DBSCAN. So that is nothing but the unsupervised machine learning model. So this class will be imported from sklearn.cluster. So this is about the ML libraries that we need. So once we import the library, after that we can start creating the synthetic data set. So we need the features or X to train the machine learning model. So here you can see that make underscore circles function is used, and we need to pass some input arguments, and one of them is number of samples or number of data points that we need. So in this case 750 data points. Now this make underscore circles will create data points in a circular fashion, so where there will be in two circles, inner and outer circle, and we can specify the ratio, that is zero point 0.3, which indicates that inner circle has a radius 30% of the outer circle. So then this is the Gaussian noise with the standard deviation zero point 0.1. So once you create synthetic data, so we X and Y we do not need because this is an unsupervised machine learning model that we are going to use. So we just need X in this case. So we can scale the data set using standard scaler function. Now once we get so let us just display the shape of this. So you can see that it has got, the X has got 750 rows and two columns, 750 data points. And it's a two-dimensional data, means two features are available, X1 and X2. And so let us just display first to five rows. So you can see that these are the first five data points, six data points, 0 to 6, 0 to 5. So then two columns will be there, x1 and x2. So once you create a data set, now it's a time to initialize the machine learning model. The DBSCAN is the one which we are going to use. It's a clustering algorithm. And while initializing, we need to give two important parameters which we discussed earlier. One is epsilon, and the second one, minimum number of samples in a neighborhood. So there are different methods to get optimum value for this, but right now we are going to use these values zero point 0.3 and 10, and we call our model as cluster. So once you initialize it, then we can use a fit function to train the model. Then after that we can predict function to get the labels or the predicted values, which are nothing but y values. So these predicted values will give the cluster numbers. And so let us just display this. So you can see that so these are the various cluster numbers that we have. The cluster numbers are available here, and you can see that it has got 0 1, that means two clusters, and -1 indicates the outliers in this case. Now once you get the labels, then it's a time to display a scatter plot. So we need x variable and y variable. X variable is nothing but the x1 or first column of the data point, and y variable is nothing but the second column of the data, so that is available. So each has 750 points. Then after that we can use a color map, which is nothing but our labels itself, that is y underscore predict, just to check. Okay, so y underscore predict. So you can see that we're going to get a scatter plot where the clustering is perfect, and you will see that there are two clusters here and there are some outliers which are indicated by -1 in this case. 0 and 1 corresponding to two clusters, and -1 corresponding to outliers or noise. So this is how a DBSCAN unsupervised technique works.